Alright, so let's derive the integration by parts formula. So, integration, this is very messy, but hopefully you can see it. Integration by parts. So let's consider an example. An example of an integral we already know how to solve. Let's say we had the integral of sine of x times cosine of x dx. And hopefully we know how to solve this type of integral by now. Let me just remind you, if you're not sure, I'll give you a hint that we have a function. We also have another function whose derivative is the derivative of that other function's. And that's a whenever you have a case like that, that's an indicator that we're going to be using u substitution, or it's probably going to be the easiest to use u substitution in that case. In this case, it's very easy. This is a very simple example. We can let u be equal to sine of x and du be equal to cosine of x times dx. Therefore, if you divide both sides of this equation by dx, a small change in x, we get du divided by, or du, the derivative of u with respect to x, is equal to cosine of x. And that is in fact true for this u, where u is equal to sine of x. We know that the derivative of u with respect to x, derivative of sine x with respect to x, is indeed cosine of x. So from this we can let u, since we've let u be equal to sine of x, we can rewrite this integral as the integral of u times du, which is very simple. It's just u squared divided by 2 plus c. And when we substitute u back in, or if we substitute sine of x back in for u, we're going to get this is equal to sine squared of x divided by 2 plus c. And that's the integral of sine of x times cosine of x dx. I'll try to squeeze that in. And that's just a basic example of u substitution, but I want to consider a more general case now. A more general case, let's say we have the integral of just some two arbitrary functions of x, both of x, and they're being multiplied by each other. How do we solve this? So let me just remind you, in the first case, we use the fact that the derivative of one of the functions was the other function. So the derivative of sine of x was cosine of x. But now, as far as we know, these functions aren't related to each other in any sense. Like, all I mean by that is they're not the derivative. One function isn't the derivative of the other function. So how do we go about solving this? Well, there's no real definite answer for that. Integration is always a bit tricky, but we can start by reminding ourselves what the product rule says. And when we first learned how to do basic derivatives, so the product rule says, I'll just use the same functions. So the product rule says that if we have f of x times g of x, and we want to take the derivative with respect to x of this, that's going to be equal to the derivative of the first function, so f prime of x times g of x, plus the opposite, so f of x times the derivative of g of x, so g prime of x. And using this, I'm just going to play around with this for a little bit. I'm going to integrate both sides with respect to x. So if I take the integral of the derivative with respect to x of f of x times g of x equals the integral of f prime of x times g of x plus f of x times, sorry, there should be a dx here. There should be, because we're integrating with respect to x, so there should be a dx here. Oh, I always forget to add the little dx. But it's important that you do. G prime of x times dx. Okay, so now when we simplify this, we can rewrite this as, well, if we have something's we take the derivative of something, then we integrate it, we're just gonna get that original something, since integration is really the opposite of taking a derivative. So if we take the derivative of f of x times g of x and we integrate f of x times g of x, we're just going to be left with f of x times g of x. And that's going to be equal to the integral of f prime of x times g of x. And now I'm going to break this up into two integrals, right? And I can do this because when we take the derivative of something, we take the individual terms, the derivatives of the individual terms. So when we integrate something, we can integrate the individual terms. So this is going to be times dx plus, this is a plus sign, not a t, plus the integral of f of x times g prime of x multiplied by a small change in x. So this right here is essentially the integration by parts formula. You'll often see it in this form. If we subtract, I'm going to subtract this second integral from both sides, and we're going to be left with f of x times g of x minus the second integral, so minus f of x times g prime of x g dx. So I'm subtracting this right here, minus f of x times g prime of x dx is equal to that other integral. So I'll write it down here, maybe in a different color, is equal to the integral of f prime of x times g of x dx. And maybe you'll see it in this form. This is the exact same thing as where I'll just say f to be equal to u and g to be equal to v. So we have the integral of u prime v is equal to these two guys, u times v minus the integral of the opposite integral of u v prime. And this right here is probably the most likely form you'll see the integration by parts formula in. And in the next couple of videos we'll learn to apply this integration by parts formula. So essentially what this says is we have some function, and we have the derivative of some function is multiplied by another function that's equal to all of this over here. And we're going to learn how to use it in some basic examples in the next few videos, so stay tuned for that.